Hello everyone, welcome to our session on collections in Java, the basic concepts. The collection framework, a brief overview. Here we'll be covering just a brief overview of the collections framework. Actually, the collections framework is a very huge topic and it's not, we can't complete it in a very small time session. So here in this session only a brief overview or a nutshell form of the collection framework is being presented to you. So the agenda for today's session is Java collection framework, an explanation on the collections framework, then the collection framework hierarchy, a hierarchical representation of the interfaces and the classes under the collections interface, then the iterator interface, and the implementation of iterator, how does it work, and an example showing its implementation. So there will be speaking to you about, we'll write a program in Java and show how the iterator is going to work. So that is what is the agenda for today's topic. So hope you'll enjoy the session. So Java collection framework. So the java.util package contains one of Java's most powerful subsystems, the collections framework. So the collections framework comes inside the java.util package, and it is one of Java's most powerful subsystems also. Now, the collection framework is a sophisticated hierarchy of interfaces and classes. So we have to know that the collections framework contains many interfaces and classes that provide state-of-the-art technology for managing groups of objects. So groups of objects can be managed through these collection framework only. So that is why we are using this collection framework for. So next, the collections or the containers that groups multiple items into a single unit. So when I come here, I have to tell you that we are grouping a group of objects into a single unit in collections. It's something similar to arrays, but in arrays, the same way, arrays also contain, they group objects into a single unit, but the difference is that in collections, in arrays are a specific size, are of a specific size. We have to specify the size of an array, but in collections we don't have to specify the size of any of the collection framework objects. So that is what is the difference. And just for grouping, this is because grouping data, and data has to be grouped and processed and all. Data is always a very important part of any language. So that is why collections is also a very important framework of the Java language. Now, it provides an architecture to store and manipulate group of objects, and using Java collections, various operations can be performed on the data like searching, sorting, insertion, manipulation, deletion, etc. So in all these ways, the collection framework is a very important framework, and data is also a very important part of any programming language, and that's why the collections framework is a very important part of the Java framework, and it's a very huge framework, and we can't restrict to a particular, because even now it's going on growing. It's growing even now. In each and every time a new function is added or a new feature is added, it's being added into a particular frame, into the same framework, and each and every time a new version is released. Now we'll come to the collections framework hierarchy. Here, the dark blue boxes, they represent the interfaces, and the light blue boxes, they represent the class. The thick arrows, they represent extends keyword, and the dotted arrows, they represent implements keyword. So what is meant by interface and class? I've already spoken to you. Then extends is when you extend a particular class. A subclass is created, you use the extends keyword, and when a class or an interface is implemented, or then that is when we use the implements keyword. So whenever we are implementing a particular interface onto a particular class, we are using the dotted arrow. And whenever when you subclassing a particular class, or when you are from an interface also you can create a sub interface, when that is done, we are using the extends keyword. So the arrows are represented in such a manner. Now we'll come to the IEEE interface. So before that, let me concentrate on the collections interface. The collection interface is actually a sub-interface of the IEEE interface, because collection objects have to traverse through the data. Collections is always a collection of data, and we have to traverse through the data. And so for traversing, you need the IEEE interface. Now inside the collections framework, we have three sub-interfaces. They are list, queue, and set. The list interface has got this sub-interface subclasses, that is array list, linked list, vector. These three classes actually implement the list interface. Similarly, the vector class is a subclass is the stack class. So actually we are supposed to speak about the array list, linked list, vector, stack, and everything. Each of these classes actually will be speaking also, but now it's not possible. In this session I am not covering it. In our regular sessions we will be covering about each and every classes also. Collection classes and collection interfaces. So here again, next we'll come to the queue. Queue is first in first out format. In list, actually the data are duplicate data can be added. In the queue, the data is in first in first out. DQ is a sub interface of the queue. It is the first in first out, as well as in the stack model, that is last in first out. So both can be implemented using a DQ. Then we come to the array DQ. Array DQ is a class which implements the DQ interface and the linked list class. So both the features will be present in the array DQ. Next we have the priority queue. The priority queue class implements the queue interface. Next we have the set interface. Set is an interface which contains data where duplication is not possible. It's something just like the list, but then the data is displayed in any order. But then we have the sorted set where the data is displayed only in the ascending order. So that is what is and it is a sub interface of the set interface. Now set interface also contains certain classes which implements the set interface. They are the hash set and the linked hash set. And sorted set contains the tree set which implements the sorted set interface. So all these interfaces and classes will be discussed in our regular sessions. Now here, and we'll do many problems also. These certain examples will also be done with these classes and interfaces. And tree set and tree map and all, when we come to tree set and all, we have something known as a comparator and comparable interfaces and all, which are newly added. And then so these things also will be covered. So how it works, we'll do examples with them. Now we'll come to map. It is an interface. Its a sub interface is sorted map, whose sub interclass is that is the class which implements the sorted map is the tree map. And map interface also contains two sub classes which implement it. They are hash map and the hash table. So here we have even more classes and even more interface have been added into the collections framework. As I told you, it's a very important framework. So each and every time new classes and interfaces are added into it, and each and every time a new version, a new function and features, when they are added, a new version is created, and the new version contains this. Next we come to the iterator. See, what is an iterator? As I told you, to traverse through the collection of the collection contains many elements, and we have to traverse through it. We use the iterator class. For example, if you want to display each element, one way would be to employ an iterator, which is an object that implements either the iterator or the list iterator interface. Iterator enables you to cycle through the collection, obtaining or removing the elements. But the list iterator extends the iterator to allow bidirectional traversal in a list and the modification of the elements also. So both these things are made possible and through the list iterator. Now you can see this diagram here. This is the way you consider this as a list of elements, and then the first position whenever when a list is created, you want to see the first element, you have to call the next element method. When you call the list, create the list iterator object with the list element, then you get you have to use the next method, and then we get the first element. Only then we'll be able to display the first element. Then we can traverse using the next method again and again. And after traversal, when the has next method can be used to see whether there is an element in the next position. Now, if there is no element, that is, when it returns false, then we have reached the end of the list. That is what it means. So this is how the iterator works. But if it is a list iterator, we can move in the forward as well as in the backward direction. Now, we'll speak about some of the methods that is present in the iterator. So, public void, default void for each remaining, the consumer super E action. This again is the implement added by JDK 8. The action specified by an action is executed on each unprocessed element in the collection. So, if any unprocessed element is also present in the collection, that is what is the method executes on it. Now, Boolean next has next. It returns true if an element is present, otherwise it returns false. Next, it returns the next element, throws no such element exception if there is no element in the next element. Now, default void remove, it removes the current element, throws illegal state exception if an attempt is made to call remove that is not preceded by a call to next. That's because only if you say next, you come to the next element, and only then you can remove the current element. So the default version throws unsupported operation exception also. So next, a simple program using iterator. Here we'll see both the use of an iterator and a list iterator. See this simple program. We have to import java.util.asterisk over here just because the collections framework resides in the util package. Then class iterator demo, public static void main string array of args. First we create an array list. So array list of string, here we are using generics, implementing generics also. Generics has been implemented in Java from the 5th version of JDK 5 onwards. We can see generics implemented in Java. So early array list actually is something which holds any type of objects, but then if you implement generics, then data of that particular data type can only be contained in that particular array list. So here string ARRL will contain only string data type. Now new array list string, add the elements to the array list. So ARRL.add A, ARRL.add B, ARRL.add C, then ARRL.add B, then ARRL.add Q, ARRL.add R. So the data are being added into the array list. Now use iterator to display the contents of the array list. Here system.out.print original contents of the ARRL. Iterator string itr is equal to ARRL.iterator, while itr.hasNext. Here I have created an object of the iterator. Then I say hasNext. While there is value in it, string element is equal to itr.next and system.out.println element plus double quotes with space. Now system.out.println modify the objects using iterator. Last iterator string litr is equal to arrl.listIterator, while litr.hasNext string element is equal to litr.next, and litr.set element plus, in double quotes you put a plus sign. So here I am adding a plus sign into the element. So I have made some modifications. That's what I told. In the list iterator, any modifications can be made, and here I am printing the modified contents. So system.out.println modified elements contents of ARRL. Now itr is equal to arrl.iterator, while itr.hasNext string element is equal to itr.next. System.out.print element plus double quotes. So here the simple modified elements are printed out. Now the system.out.println to display the list backwards. That again is possible using the list iterator. So system.out.print modified list backwards, while litr.hasPrevious system string string element is equal to litr dot previous. This is the method for moving in the backward direction. Now system.out dot print element plus double quotes, and then system.out dot println. So this is the simple program, and now I think you would have understood something at least. Now we'll come to the output of the program. The original contents of the array is A, B, C, P, Q, R. Modified contents is A plus, B plus, C plus, P plus, Q plus, and R plus. And the modified list backwards is R plus, Q plus, C, P plus, C plus, B plus, and A plus. So we have seen this is the output. So this is how the iterator works. Iterator object works. So this is what I was trying to show you. Similarly, we have even more things to learn in the collections framework. We have something known as a comparator, comparable, and then the different classes, how it works, this different collection classes, then the interfaces, what each and every interface is up to. So we have many things to learn. So, and each and every version has brought in many things into it. So that we'll be doing it in our regular sessions. So please attend our sessions. So you think if it's good enough, then please like, share, and subscribe. And thanks for attending our session on collections in Java.